I think we'll all agree that you've got to keep a close eye on the wear in your EMD. In fact, there's a lot of things that can go wrong that you should look for as you inspect the rings and liners, pistons and carriers during your airbox and oil pan inspection. And there's a test we call a lead reading that helps us tell how much wear we've got on the parts that we can't see, like the bearings. What we're going to do in this program is show you how to make an airbox and oil pan inspection and how to take lead readings. When you get through watching it, you should be able to do an inspection without any trouble at all. The main thing you need to keep in mind as you watch this program is how important these inspections are, because this is the only way you're going to be able to keep track of how much use you're getting out of your parts. This program will do more than just show you how to do the inspection, though. It'll answer the specifics for you. How worn can the rings be before they have to be changed out? Sure, you might see scratches and scuffs on the piston and liner, but how do you know what's serious and what's not? And just exactly how fast are these parts wearing? While you're doing one of these inspections, these questions and others are going to come up. So we'll try to answer them for you in this program. We'll start with the PMS, the Programmed Maintenance Schedule. The PMS has been put together to give you a way to compare the wear life of all the important moving parts in the EMD. You'll find a set of the forms with the EMD workbooks. For the inspection, we'll be using the Power Assembly Inspection Log and Lead Reading Chart. On the inspection log, you'll be keeping notes on liner wear and liner damage, piston wear and piston damage, and the condition of the piston rings. The lead reading chart will help you keep track of wear on the parts you can't see, like the bearings, or something hard to see like a slightly bent rod that'll only get worse with use. But before you begin the inspection, the basic engine information needs to be filled in, like the engine model and serial number, and your name. Then you should pull the fuse on the engine you're about to look at to make sure it doesn't get started while we're inside the thing. And just to be safe, kill the starter air and bleed the pressure off. You sure don't want to get caught with a finger inside that cylinder when somebody accidentally hits the start button. Do you? There's another part of the PMS that will tell you when certain things should be inspected, a kind of checklist. The first of these checks is a quickie inspection due every 700 hours. You won't be filling out the PMS logs, but you will be checking for minor leaks, and you ought to give everything a general cleanup, like in the airbox. It'll really get dirty. You'll probably see quite a bit of carbon mixed with a little oil that slobbered out of the cylinders while the engine was running without a load. Maybe some water condensation. Go ahead and clean up the trough real carefully and wipe it out. Don't try to drain chunks of carbon or any other objects through the drain hole. They'll end up plugging it. You can use a little diesel fuel on a lint-free rag if you need to loosen it up. Get it as clean as you can, but don't use an air gun at all. Compressed air will blow carbon and stuff into the air intake ports of the cylinders, and that carbon will really eat those cylinders up. Don't mess around the liners, and especially the air intake ports at all. Keep away from them. Just clean up the trough area of the airbox. While you're in there, check the drains. Since most of ours are field installed, yours may be different. Make sure they're draining. If not, shoot a little air through them. If compressed air doesn't open them, you can use a spring wire type probe to try to clear it out. Next, check the water inlet manifolds and water inlet jumpers to each cylinder. If you noticed water in the airbox, it's probably because one is leaking. You can tell which one it is because there will usually be a little rusty looking path running from the seal down the side of the liner, or you might just see water leaking at the jumper. If you see this, you'll have to replace the seals because the leaking water that accumulates in the airbox will affect the operation of the engine. Also look for leaks on the outside of the liner around the air intake ports. If a leak is coming from the inside of the liner, it could be because of a cracked head or liner, or it could be the liner to head seal area. If the leak is on the outside of the liner, the head to liner seals or a head core plug may be the problem. It may even be the joint where the liner water plates were brazed on. You can find out more about these problems and their repairs in Power Assembly Repairs. Okay, if you need to repair a leaking water jumper seal, make sure that your immersion heater is off. It should be if you've pulled the main fuse, like we mentioned earlier. Drain the cooling water, but don't dump it. You'll be reusing it. Then pull the jumper completely off. Both the manifold seal and the cylinder seal should be changed if either one of them is leaking. You can use a little diesel to help clean it up if you need to. Once all that is clean, you can put a new seal in the counterbore of the jumper and reinstall it. First, make sure that the deflector is in place in the liner. Then install the U-bolts loosely around the water inlet manifold. Start the cylinder bolts to hold the jumper in place while you slide the gasket in between the water inlet manifold and the jumper. Then, snug the cylinder bolts down and tighten the U-bolts to 15 foot-pounds. Next, pull the cylinder bolts out. If they bind or if the jumper moves, then it'll have to be loosened and repositioned. Now, the cylinder bolts should be torqued down to 30 foot-pounds. The water manifold bolts should be torqued to 15 foot-pounds. Once you've got the water jumper fixed, refill the engine. If you're replacing your cooling water, mix Nalco 39 granules into the water. Next, check the seals on the airbox handhold covers. Make sure that they're not twisted and they're in good condition so they'll seal up good. Take the rubber gasket off if you have any doubts and get a close look at it. It ought to be flexible like this one is. Before replacing the covers, look for signs of ring, liner, or piston distress. When you put the covers on, you ought to tighten them with a wrench to about 20 to 30 foot-pounds. And next, the oil pan inspection. One of the first things you ought to do is take a sample of your lube oil. Get at least a pint from the middle of the sump while the engine is warm. It'll need to be sent into a lab for an analysis. Be sure you include the right information so you'll know which engine the report is for. You'll need to put down the running hours of the lube oil and filters, brand and grade of oil, and the total hours that the engine is logged. Put the date and your name on it, too. Then give it to your warehouseman. He'll make arrangements for getting it to the lab for you. The analysis can really be revealing. When the results get back, you'll be able to tell how much contamination the oil's been subjected to, and you might even be able to figure out where it's coming from. Be sure to go over the analysis with your supervisor when it returns. It'll help in troubleshooting. Take a look at the total base number. If the TBN is deteriorating pretty quick, you can figure on a poor additive package or fuel contaminated with sulfur. Take a look at the liner skirt. If you see any signs of milling here, tell your supervisor immediately. You've got a bent rod that's about to do some serious damage. Before you cover the oil pan area back up, you need to make sure that all of the bolts are tight. Check them all. The basket bolts, P-pipe bolts, you don't want to retorque them, just make sure they're tight. You might take a quick glance at the condition of the blade rod bearings while you're looking. If the area you can see looks bad, you might have to pull them. The oil pan cover seals should be checked just like the airbox seals. Well, that's what we call a minor inspection and cleanup, and you ought to do one every 700 hours. And later on, after about 1,400 hours, you'll need to make a more thorough inspection, a major inspection, and you'll need a few tools for it, so get them ready before you start. You'll need a flashlight, a feeler gauge, an assistant, and of course your PMS log sheets, especially the ones that have spaces for the ring and cylinder wall conditions. And you'll need a P-pipe gauge. Now don't forget to make sure that the engine can't be started once you get inside it. Retrieving a finger from a cylinder can be really tedious. Okay, next, make sure that the cylinder test valves are open. This makes it easier to bar the engine over. The first thing you should do is look at the piston and piston rings, starting with cylinder number 1. Bar the engine over so you can get a good look at the top of the piston through the air inlet ports. You should be able to see a burn pattern on the piston crown. It'll usually be a burnt orangish color, and it should be in the shape of a circle. This is normal. It tells us that the piston is rotating, like it should when the engine's running. Now, if it were star-shaped, we might have a problem. We'd be looking at the pattern created by the spray jets of the injector, which tells us the piston hasn't been turning. It doesn't necessarily mean that there's a problem, but you should log it in your comment section of the PMS just in case. If you notice that the top of the piston is wet, it could be due to a leaky injector or water seals. If it's the injector, it'll have to be replaced. Or if it's water, it'll either be because of a leaking cylinder head O-ring, or maybe a cracked head or liner. Either way, the problem will have to be fixed, and that means pulling the head or the entire assembly. Next, check the cylinder walls for scuffing or scoring. We'll go over the cause of these in a little bit. Now let's take a look at the compression rings. You'll have to bar the engine over to get a look at them. You'll have to judge them for wear, condition, and performance. Now check how worn they are. The first one's the most important. If it's got a pretty new ring and it's got deep grooves in it, it's classified as a Class 1 ring. If they're worn, but you can tell that the grooves are still there, it's a Type 2 ring. If it's still shiny, but it doesn't have any more grooves, it's called a Type 2A ring. But when the chrome's worn down and you can see two different metals showing in alternating horizontal bands, it's a Type 3 ring. When it gets this worn, you'd better start thinking about a ring job. A Type 4 ring is worn down completely, and you'll have to replace the whole assembly. The top 3 rings need to be classified. The 4th ring doesn't have a chrome face, so it's either good or worn out. If it's shiny across the entire face, that means it's worn out. If you see alternating horizontal dark and light bands, it's okay. A G on the PMS will indicate that this ring is good. A W means it's worn out. There's a space for each ring in each cylinder. That tells us how much they're worn. Next, check them for their condition. If you see brown streaks on the face of the rings, you might have a problem. It's probably blow-by. Light or moderate blow-by itself isn't that much of a problem, but what caused it could be. It could be a weakened ring, or rings that never seated themselves right to the shape of the cylinder wall. Or it could indicate a newly broken ring. A broken ring will either be loose in the groove, or it might be stuck by carbon buildup. If it's been broken for a while, it might be completely black, not just streaked. If you see any of this, log it on your ring condition log sheet, whether it's only blow-by, either light, moderate, or heavy, or whether the rings are chipped or broken. Okay, that's the condition. Now to check for their performance. The best way to tell this is to check for carbon buildup between the rings. The buildup on this piston is very light, but we'll use it to show you where it will occur. There will usually be a little carbon buildup above the first ring. That's okay. Buildup between the first and second ring indicates a little wear on the top ring, but that's okay too. Carbon buildup between the second and third ring tells us that there's wear on the first and second ring. Carbon between rings 3 and 4 means the rings are going to wear even quicker. When you see heavy carbon buildup, be sure to write it down in the comments section of the PMS logs. Next, you'll need to check the ring-to-land clearance, or the gap between the compression ring and the compression ring groove on the top ring. Use a feeler gauge to figure out how much wear there is in the ring area. Put it down on the land clearance part of the PMS. A new piston ring will have a nominal clearance of 6/1000ths of an inch. You're okay up to 15 thousandths. More than that, and you might end up with a broken ring. Now, there are 2 other rings on the piston, but you won't be able to get a look at them. They're the oil control rings. You'll just have to assume that if the compression rings are okay, and there isn't anything that makes you think there's a problem, the oil rings must be okay too. Bar the engine over slowly so you can check the sides of the piston. Make a note of any scuffing or scoring that you see. There's a place for this on the PMS. You may see places where the phosphate coating has worn off and bare metal is present, but this is normal wear. If it looks like there's only normal wear and you don't see any signs of scuffing, the piston is in good condition. Okay, now bar the engine over until the piston is at bottom center again. Check the condition of the liner walls. First, look at the air intake ports. If you saw a broken ring earlier, you might have some port milling or gouging. This is kind of an extreme case of port framing, but if you see any evidence of this, you can bet that it'll only get worse. If it looks like it's okay, check the hone marks in the cylinder walls. Now, if your engine's using chrome liners, it won't have hone marks. Most engines that run these chrome liners are using a high sulfur content fuel. Regular cast iron liners should have a crisscross hone pattern that's at about a 45-degree angle. Their presence should be logged because this is a good indicator of how early the wear has occurred. Rate the amount of wear in percentages on the logs. This one's got about 90% of its hone marks. Here's one that's got about 50%. And this one's about 10%. This is a judgment reading, but it's an important one, and it should be put in the logs as accurately as possible. We're always looking for carbon drag or discoloration of the cylinder wall, too. That's caused by carbon being rubbed into the surface of the liner. It's usually caused by running an engine without a load or lacquering due to combustion. It might look like a scratch. In fact, it might even be a scratch. But unless it's pretty bad, you only need to note it in the logs. Minor scratches like this will usually polish out once the engine runs under a load for a while. Earlier, we were talking about orangish burn patterns in the crown of the piston. If you have a star-shaped burn pattern, that's caused by things like excessive ring belt deposits, port milling, broken rings, or broken or bent P-pipe. A P-pipe that is broken or off-center just won't squirt enough oil into the piston underside. And what will happen is heat will build up and affect the bearing surfaces. If it goes on long enough, it'll even ruin the cylinder walls and piston. There's a little gauge called a P-pipe gauge that's used to check this alignment. It fits into the pipe like this. Bar the engine over until the piston is at bottom center. Now, with your fingers, see if you can turn it. It should be easy to turn, and you shouldn't feel any binding at all. If it doesn't turn freely, you'll have to replace the P-pipe. Anything like this that you find, write it down on your PMS forms. Don't try to bend it to make it fit right. If you bend it, the stresses that are put into the pipe might cause it to break. If it's bent or no good, replace it. It's held in place by 2 fine-threaded bolts attached to the oil manifold and 2 coarse-threaded bolts on the bottom side of the liner. Once they're removed, it should slip right out of place. Put a new gasket on the manifold end and slide the new one into place. Don't mix up the coarse and fine-threaded bolts. Torque all of them to 20 foot-pounds. Then recheck it with the P-pipe tool. It should check out okay. If it doesn't, try another pipe. If, after you've tried several new P-pipes, you still can't seem to get a proper fit, you might have a twisted rod or a damaged oil manifold. Whatever the problem is, you can be sure that it's going to get worse, maybe even this bad. Either way, the power assembly will probably have to be replaced, or the oil manifold might need to be repaired. Finally, take a sample of the oil to have it analyzed. We want to know what's happening to the engine in areas that we can't see or know about. Contaminants can cause damage to sensitive bearings like this. Compared to a new one, you can see the difference. This is the result of corrosive pitting. Okay, we've checked one power assembly. Now you check the rest in firing order. And the firing order is on this plate on the side of the engine. Once you've checked all the power assemblies, you can go ahead and replace the handhold covers. There's one last thing, a look at the top deck. Let's hear what Don McCrossan has to say about it.
You know, the top deck inspections are every bit as important as the airbox and oil pan inspection performed every 700 hours. Now, for purposes of this demonstration, I have the engine shut down so you can hear me. Now, normally, with the engine running at idle and the top deck covers raised, you would inspect for proper operation of all the running gear, such as the rocker arm rollers, the camshafts, the camshaft bearings, make sure they're oiling, the same as the rocker arm rollers should be oiling. The rollers and the cam lobes should be checked for spalling or any evidence of distress. The valve bridge springs should be checked to make sure there are no broken springs. The valve bridges themselves should be checked to make sure they're oiling. The rocker arm adjusting nuts should be checked to make sure there are no loose ones. The crab studs, the liner studs should be checked to be sure there are no broken ones. Fuel leaks should be checked for at the 2 ends of the fuel jumper lines, also at the injector rack. After checking for fuel leaks, you'll want to inspect for evidence of water leaks. Each cylinder should be checked at the water discharge elbow and between cylinders down in the trough for evidence of water running. Also look to see if there's any evidence of water at any of the core plugs on top of the head. After the inspection is completed and before the top deck covers are closed, the seals should be inspected. They should be wiped off and checked to be sure they're in the groove and not twisted. Then, before closing the cover, this seal surface should be wiped clean so that there's no leaks after the cover is closed.
Okay, thank you, Don. That covers just about every visible area that can be inspected. But there are 3 areas that aren't visible that can be checked pretty easily, too. These are the bearings on both ends of the rod and the thrust washer that acts like a kind of bearing between the piston and carrier. If there's any real wear on the bearings, it'll show up as an increase in the distance between the piston head at top dead center and the cylinder head. The same thing with the thrust washer and washer platforms. But you can check for this wear by measuring the gap between the piston snap ring and the carrier on the upstroke of the piston. The bearings, piston pin, thrust washer, piston and carrier thrust platforms can wear up to 30 thousandths of an inch. Measurements should be recorded on your PMS lead reading logs. There's a place for them, and there should also be a reading from when the assembly was new. Your lead readings are supposed to be taken on each cylinder every 2,500 hours of operation, or any time you feel that the cylinders might have been run during a high wear situation, like improper bearing lubrication. The lead readings for all cylinders should be recorded on the PMS log sheet. And these readings should be taken after a power assembly has been replaced to make sure the assembly is within specs and to give you readings to compare with later on as a reference. They're pretty easy to take. All you need is some 1/8-inch lead wire or solid core solder, an old piston to help you shape the lead, a micrometer, and a piece of small copper tubing or something else to help you get the lead in and out of the cylinder. If you have one of these lead holders, you can use it to help you conserve lead. Just slip enough lead wire into each end so that the wire is at least 1/8 of an inch from the outside diameter of the piston. If you're not using the lead holder, cut a piece of 1/8-inch lead to about 11 inches long. Bend it in half and squeeze the bend with a pair of pliers to flatten it. Then use an old piston to get the lead shaped right. Stick the bent end into the screw hole in the crown and bend the lead to fit the contour of the crown. Make sure the ends of the lead don't go over the edge of the piston crown. Starting with the first cylinder, bar the piston around to bottom center. Check the crown of the piston for carbon deposits. If there's a lot, this will affect your lead reading. Take this into consideration. Stick the lead in through one of the air intake ports. This little stub will help you in getting the lead positioned and holding it in place once it's inside the cylinder chamber. It should be lined up so that the lead is pointed in the same direction as the crankshaft. You might have to take a reading several times before you get a good one. Next, bar the engine over one turn. As the piston reaches top dead center, it smashes the lead. This gives us a good accurate reading of the distance between the piston crown and the cylinder head. Just pull it out and use a micrometer to get your reading. Be sure to measure the thinnest section on each end of the lead wire. And write the results in the compression lead readings log. The difference in readings between the ends of the lead wire shouldn't be more than 5 thousandths of an inch. If it is, take the reading again to be sure of the difference. It could be that the lead wire moved out of position the first time, or it could be because of a carbon buildup. If it's more than 5 thousandths of an inch, you might have a bent rod, or an unevenly worn thrust washer, or unevenly worn piston pin. The compression clearance should be between 20 thousandths and 68 thousandths of an inch. Watch the progress of this wear real carefully. Whenever you see that you've got more than 30 thousandths of an inch of wear, the assembly should be replaced. Or if you see a sudden increase of, say, 10 to 20 thousandths of an inch, you know that a problem exists and it should automatically be checked out by your supervisor. It could be a bad piston pin bearing, or thrust washer, or a bent connecting rod. Or if you notice the same sudden increase in the opposing cylinder too, then chances are it's due to crank journal problems, or possibly a bent connecting rod. You might even experience a slight reduction in the lead readings due to a normal buildup of carbon. Take this into consideration when you take a reading. Well, we've covered a lot of ground in this program. I guess you can see how important these inspections are. By now, you should have a good idea of exactly how to do these inspections. Let's take a look at what you should have learned. We've talked about the PMS, Programmed Maintenance Schedule, and how to fill in the condition of the rings, piston and liner, ring land clearance, and lead readings. We went over replacement of leaking water jumper seals and bad P-pipes. We talked about taking oil samples, and we went over lead readings. We also got an idea from Don about what was involved in the top deck inspection. So, you should be able to go pull off an EMD routine airbox and oil pan inspection. And remember, if you run into anything that might be a problem, but you're not sure, ask the master mechanic. He's there to help you make those final judgments.